Hello everybody and welcome to our first class in automata and the theory of computation. The name of your class though is automata and formal languages, I believe, but the idea that we will be working on this semester is effectively this covering three fundamental areas of the theory of computation. And I will talk to you about these areas as we go along. But with this short video, I wanted to basically welcome you to the class and tell you a little bit about what we will be covering as we go along. And I'll go over your syllabus basically in this video. It is a quick overview, and then in the next part of this, the first unit, as you will see, we will discuss a little bit about theoretical concepts and foundations that we need in order for us to be able to proceed with this course. Okay. To begin our journey, the first thing I would like you to learn about this class is how this class will be administered and what are the requirements in different components that are expected from this class. All of this information you can find in your class syllabus. The class syllabus is uploaded on the Blackboard. On the left hand side there's a tab called Syllabus and I guess class materials or something like that, and then if you click on that link you'll be able to see this PDF file. This course is a graduate course, COSC 6346, and it's one of the 4 required courses for the computer science track. The computer information systems track, the students can use this course as an elective. It's administered this version of this class online. There is also a face-to-face component to this class, and you will be able to find out the class location and the time if you wanted to attend the face-to-face class, if you had questions or there were things that needed more I guess synchronous face-to-face communications. I will be happy to see you in the face-to-face version of the class. It's actually an ITV class. Basically, we have classes both in Sugar Land and Victoria. If you have any other questions about the class, I'm hosting a office hour online on the Adobe Connect servers. It's Thursdays from 5 p.m. to 6 p.m. and if you have any questions you can attend those office hours. The link to these office hours is on the Blackboard, on the homepage of the Blackboard, on the homepage of the class. On the Blackboard you can click on it and automatically log into the office hours. It does ask for username and password. You can either log in as guest, just provide a name, or use your UHV username and password to be able to access the link. I also have an office in Victoria in the University West, room 263, and you will be able to visit me if you have any other questions outside of the office hours, or you can call my office at the number provided here. And of course you can email me at any time with any questions you have. I'll try to answer your emails within 24 to 48 hours of the time that you send it. If it took longer, please either resend an email or call my office. I receive a bunch of emails, so there is a chance that I may miss the emails. However, if you put any email, if you have any communications, and you submit that email through the messages and message system of the Blackboard, I will be able to access those. So it's less likely that I would miss an email or communications from you if you send it through the Blackboard. However, please still, as I said, give me 24 to 48 hours to be able to get to your questions and messages. The information that you'll be seeing here that I will cover may change depending on how fast or slow the class is going, or what contents or information need more elaboration and discussions. But generally we try to stick to this schedule, aside from occasional needs to modify some of these schedules, and that is your responsibility to be aware of, meaning that although I'll try my best to stay within the focus of this content that I'm presenting in the syllabus, any changes will be effectively discussed at your online class through either announcement or email message or messages. And it is your responsibility to log into your class at least twice a week, at least. And this class is highly theoretical, and it may require a lot of work on your part to put into it to have a satisfactory outcome. So what is this course about? This course is effectively introducing you to fundamental concepts of the theory of computation and formal languages. What that means is that we will look at the mathematical concepts that are at the core of any computing machinery, any computing device. And we will analyze those, and we will try to look at studying the foundations of computation mathematically. And the topics that we will cover, and I'll discuss a little bit later, are understanding what are the mathematical tools that you need to have as a computer scientist at your disposal to be able to study the science of computing. Then we will build on these mathematical terminologies and mathematical concepts, the idea of creating a finite automata, meaning we will create a machine that with very limited amount of memory will be able to look at an input and decide whether that input is computable or not. And we talk about what that means as we go on, which then gives rise to the regular languages. From that point, we'll see what the limitations of a finite automata is, what kinds of things it can process, and what kind of things it cannot process. And then from that, we look into context-free grammars and context-free languages, which then in turn allows us to create a machine that we call push-down automata, that uses a limited amount of local memory and a stack to be able to process. We also further look at the limitations of those machines, and then we will look at the Turing-Church's theorem. It's effectively, or thesis, it's effectively the idea of what is at the core of a computing machine, that a lot of the nowadays computers are effectively built on top of, and those are called Turing machines. Then we will take on into three different aspects of computing, based on the concepts that we built so far, and those are complexity, computability, and decidability. And then that should conclude this course, depending on how far or how fast or slow we evolve as we go on in this class. Some of these concepts I may cover more in details, and some with a little less details into them. If you wonder what kinds of text or required materials are required, effectively I don't require any kind of text. However, these are the two texts that I put here as recommended, meaning that you don't necessarily need to buy these textbooks, because a lot of the concepts that we will be covering, I'll cover them in details with video lectures. Also, they will be covered in the live classroom, and I will post, if needed, some videos of those discussions as well, and also your PowerPoint slides and lecture notes and further reading materials should have the contents you need. But I do recommend you to buy these two textbooks if you could get them. The Introduction to Theory of Computation by Michael Seipzer from MIT, and the Introduction to Automata, Theory, Languages, and Computation by Hopcroft, Wani, and Ullman. Both of these textbooks are now in their third edition, and these are really fantastic books, especially if you get interested in the theory of computation and you wanted to pursue either a profession or an academic career in the computer science area. these are very fantastic resources and references for you to have. Now that we talked about what the concepts of this textbooks, this course is about, how would you be assessed throughout the class? What I have in mind at this point is a four faceted kinds of evaluation of your performance. There are 2 exams and assignment-based assessments that I will be looking at. Since this is a theoretical class, the assignments are going to be highly theoretical and mathematical in nature. Not necessarily calculation-based mathematics, but effectively kind of discrete math kind of concepts. And so you will have 3 to 5 homework assignments, which basically are write-ups, and then I will give you 1 or 2 research projects, again depending on how we are progressing into this course, and cumulatively these 2 will make up to about half of your grade. 30% your homework assignments, and your research projects are going to be 15%. Then towards the middle of the semester, right about around the time that we finish with the finite automata, we will cover that concept, that area in a midterm, and then we go into the push-down automata, context-free languages, and Turing machines, and then we'll have the final exam at the end of the semester. The final exam will be still cumulative, meaning that you should expect that the final test to cover everything that we covered from the book. The focus would be on this latter part of the semester, but you still may get questions from the beginning of the semester as well. And of course, the participation in this class is 5% extra credit, and that means being on time, in your and diligent in your assignments, participating actively in the classroom if you needed help, seeking help, and if other students sought help, providing it to them will earn you the 5% extra credit. The grading rubric for your final grade will be according to this table in the middle here. The letter grades are A, B, C, D, and F, and the distribution is here. Any grade more than 87 cumulative, when you put the weighted averages of whatever you have from the table on top of this page, calculated. If it's greater than 87, it's an A. 75 to 87 is a B. 62 to 74 is a C, and so forth. I do have a late assignment policy, and the table shows you how the grades will be calculated, or rather the penalties will be applied to the late assignments. So depending on how many days you're late in submitting your assignment, and a day is the 24 hours right after the assignment is due, it will be penalized by taking out 2n squared percentages out of your assignment. So if you're not late, and let's say that your grade was 92, it's going to be 92. If that 92 that is graded and it's 92, it was a day late, it's going to be automatically dropped down to 88. 2 days late, 77. 3 days late, 58. 4 days late, 33. If it's more than 4 days left, unless you do have a justifiable reason for being late, that you need to discuss with me at least a couple of days before the assignment is due to get a new due date. Your assignment is not going to be graded. The contents that we will be covering, in an ideal format, I would like to cover all of these. So introduction to mathematical concepts, probably a week, then finite automata a week, regular expressions a week, non-regular languages a week. We'll have a midterm at that point. Context-free grammars and push-down automata will be about 2 weeks cumulatively. A week was spent on non-context-free languages. Then we go into Turing machines, decidability, complexity, and NP completeness, and then have a final. Now, that is an ideal case in that, if everything goes according to the plan, and most of the time it doesn't. So, depending on what happens throughout the semester, we might cover some of these concepts more, some of these concepts less. But what I'm expecting we will eventually cover is go over the mathematical concepts as much as we need to get a good footing there. Then we move into finite automata, regular expressions, and non-regular languages. And we cover those in the greatest amount of detail possible because those are very foundational. Then we'll go into context-free grammars and push-down automata. If I see that we are moving along reasonably, I go into details in those contents. And if not, you might just skip a couple of concepts from there, because at that point you should be able to pursue details and further areas of context-free and push-down automata on your own. And then same we do with Turing machines. We might go over them relatively quickly and not too much into the detail, but effectively getting the sense of what those are and what things they're capable of and what not. And then we go into the decidability questions and complexity. So this is that, and I haven't really put this a detailed schedule of when the assignments will be due. The number of assignments I gave you, what you should be expecting, and here's what you will be effectively seeing as we go along. At the end of each of the components, major components, like towards the end of finite automata, you'll get an assignment on finite automata. For regular expressions, maybe we combined with non-regular languages, you will get an assignment on those concepts. And then you'll have the midterm. And then when we go to context-free grammars and push-down automata, you get another assignment. After we finish that, we start Turing machines. Towards the end of the Turing machines, you get another assignment. And in between these, you'll get your research project released there. And then for the decidability and complexity, again, depending on how much details we cover there, you may get 1 or 2 assignments towards the end of the semester after the midterm. And then the final exam will cover and conclude the semester. So this is the mechanics of the class and how we will be working throughout the semester. And then so I will let you take a look around in the classroom and get comfortable with what is there, and then we will start the study of the mathematical foundations that we need to go on.